All right, today we are going to learn about 3.6 absolute value functions. Today is October 2nd, and this is page 9 in our notes. One important thing about absolute value functions is they're written in the form y equals m times the absolute value of x minus h plus k. The vertex is always at hk. And when I say vertex, the graphs of these functions always look like a V. It's either a V like this, facing upwards, or a V flipped upside down like that. So we can find the vertex at the point hk, which we see here from our function. All right, so for our first example, we are going to graph y equals the absolute value of x minus 3. Let's write down the vertex of this function. I can see that it has minus 3 right there, so it's going to be 3. There's nothing outside of these absolute value symbols, so it's going to be 3, 0. All right, so now I'm going to graph this by making an XY table. And in the middle of my XY table, I'm going to put 3, 0. That is the vertex. And then for my x's, I'm going to put one number less, and I'm going to put one number more than the x value of the vertex. And to get y, I'm going to plug in 2 to this function. 2 minus 3 is negative 1. The absolute value of negative 1 is 1. I'm going to do the same thing with 4. 4 minus 3 is 1. Absolute value of 1 is also 1. All right, next I'm going to plot these points. I'm going to go to 3, 0, 1, 2, 3, 0. That's right there. 2, 1 is right here. And 4, 1 is right here. So you can see that I have this beginning of a V shape. I'm just going to follow that with my straight edge. And I am done. There we go. We've graphed our first absolute value function. Looks wonderful. All right, next, let's graph y equals negative absolute value of x plus 2. So this negative is on the outside of the absolute value bars, and what it's going to do is going to turn our v upside down. So right now, please write the vertex of this function. All right, hopefully you said 0, 2. There's nothing inside with this absolute, inside the x with the absolute value bars, and there's this positive 2 on the outside, so our vertex is 0, 2. Next, we're going to set up the xy table. All right, my xy table is going to look like this. I'm going to put 0, 2 in the middle, and I want you to write down the x values, just the x values that we're going to plug in to set up the rest of our table. All right, hopefully you wrote negative 1 and 1 because negative 1 is one number less than the x component of our vertex, and positive 1 because positive 1 is one more than our vertex. Now I'm going to plug in negative 1 here, and I have absolute value of negative 1 is 1, and then this makes it negative. So I have negative 1 plus 2, and that's equal to 1. And here I have 1, absolute value of 1 is 1, make it negative. So I have negative 1 plus 2, and that's 1. All right, now let's set up our graph. All right, so I have a 4 by 4 graph set up. I'm going to start with my vertex at 0, 2. That's right there. And then negative 1, 1, negative 1, negative 1, 1. That's right there. And 1, 1. So I can see that I'm going to have this A shape or upside down V shape for this absolute value function. All right, there we go. Let's do one more together. All right, this one's going to go fast. We have y equals 1/2 times the absolute value of x plus 2 minus 1. Find the vertex. All right, hopefully you use negative 2, negative 1 for the vertex. Please set up the table. So if you use negative 4 and 0 like me because they are easy to multiply by 1/2, you get 0 and 0. Now let's set up the graph. All right, you get a graph that looks like this when you're done. You can see that the vertex is at negative 2, negative 1. And because we have this 1/2 coefficient out in front, it kind of fattens out our V shape. All right, that's it for now. Thanks for watching.